Well, good evening. It is 7 p.m., so it is time to get going on this. So this is the live stream review for Unit 1 for Honors Physics. And I'm hopefully going to answer all the questions that you have. I put together this little, this thing, and like it says at the bottom, you can ask me any questions. And at any time, you can use the YouTube chat if you want to, although you're watching this, you're probably not logged in as yourself, or at least on your school account, and that's fine. Or you can ask me questions through Remind. I have my phone right down there, so it's ready. That's if you want to ask me a question, not necessarily be seen, or you want me to know who's asking the question, I will see that. So lots been going on. Obviously, I'm not in the classroom as much as I'd like to be at this point, but that's how having a student teacher goes. And so hopefully I've been able to help you guys by coming in there every now and then. But please continue to ask Mr. Kelly questions. Continue to ask me questions. You can use Remind if I'm not in the room, or Teams chat on a regular basis. And by watching this, though, that's a very good sign that you're taking charge of your education, because whatever reason, it's hard. Physics is hard. And I don't want you to get in the habit of making excuses for not understanding it. It is difficult. And that's just, if you knew what you were doing, you wouldn't be in the class. And so don't worry about not understanding it. By watching this, like I said, this is a very good step, a very good sign that you're ready to go with this. So hopefully, like I said, this will help you. Like it says down there at the bottom, and I don't know if I phrased it very well, but taking notes and maybe not being interactive, but being engaged with this is going to be way more helpful than just having it on in the background or watching this. Because, as much as I'd like to think that I'm exciting, this is going to be a review session for a test. It's not going to be something to keep you up. I'm not saying it's going to be that boring or anything like that, but in order to just focus your attention, get out a sheet of paper or something to write down some things, because hopefully I'm going to clear up so much stuff and you're going to want to write this stuff down so you don't have to go back later and watch it again. So that would be the first bit of advice that I give you on this, is be engaged with this. Just watching it is not going to be like a magical cure-all for every question that you might have. All right. I'm just going to really quickly, since this is the first time I've done it in a little while, it seems like it's working. And if there ever is any technical issues, just let me know and I'll fix it up as soon as I possibly can. But like I said, it's been a little bit since I've done this. And so, so let me just do something really quick here, get some ink going, and let's begin right away. There's 3 standards to the unit. And so what I did is I broke this down into the 3 standards. So I'm going to start at the beginning with standard 1, which is position time graphs. All right, so don't worry, I will get to your question if you have any, and I will get to the stuff that bothers you and the stuff that you don't understand. But I want to start at the beginning and sort of work my way forward. There will be time for I'll let you know before I go to the next section, I guess is what I'm saying. All right, so let's take a look at this. We have a position time graph, and now there are velocity time graphs and acceleration time graphs. And so the first thing you got to do is make sure you know what kind of graph it is that you're dealing with. Obviously, position time graph, it's a distance time graph. It's basically the same idea. Much different than a velocity or an acceleration time graph. So this is pretty straightforward when it comes to answering these 4 questions. You did this a while ago. What it boils down to is if you have a position or a distance versus time graph, if you need to find the position, all you got to do is read the graph. So it wants the position at 3 seconds. So I'm going to go over down, the time is in seconds. And so I go to the 3 seconds right there. I go up to here. This is over here. The position is 1 meter. So at 3 seconds, it's 1 meter. And by the way, if I ever do make a mistake, it does happen. Please call me out on it. That's part of the deal here. All right. So Hopefully I didn't make a mistake there, but it is possible that it will happen. The other thing to keep in mind, there's like a 12-second delay, I think I counted. And so I might not see your question right away. I might not be able to respond to it like instantaneously because it's live, but it's not quite live. All right, so at 4 seconds, you go over to the 4. And at 4 seconds, the position hasn't really changed. It's still at 1 meter. And don't forget to put those units, all right? It's given in meters, so I'll make sure you do that. At 7 seconds, all right, so it's like right here. And I go up, 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 and there's my little dot over at 4 meters. All right, so you get the idea here. You just read the graph. So at 9 seconds, oh, we went, what? It's weird, it's at 0. Okay, that's fine. That's what it is, right? 0 meters. And then at 12 seconds, looks like it's -2 meters. So yes, it is possible and likely that occasionally you'll get a negative number. That's fine. All right. So for position, read the graph. Question 2, what is the object's velocity at those letters? Okay. For velocity, you find the slope. All right. So for a position time graph, slope is velocity. It's different for a velocity time graph. All right. But for a position time graph, slope is velocity. You could just substitute the words slope and velocity. So a couple things I noticed when during the practices is some of you guys weren't doing what I'm about to say to do. And this should make it easier. When you have a pre-generated graph like this, where all the lines are perfect and all the data is just, given to you, and it's all nice and straight and there's no like dotted line, dots outside the line, use the endpoints to find slope, all right? So what I mean by that is for A, the segment A, start there and end there. So this is 0, 4, right? And this is right here, over 3 and up 1. So use the endpoints. Don't try to like this this would work, but I feel like you're making a little bit too difficult for you. You're adding a little layer of complexity that you don't need to add. You want to keep it simple because remember, you're gonna have a test. You're gonna be like, I don't know how many questions, but you're gonna want to keep moving on this. So you don't want to like, you don't want to overcomplicate things. It's a very honors thing to do, to overcomplicate things, but try to avoid that. So slope. Slope is the equation for slope is on the equation sheet. So if I pull up the equation sheet, it's going to be on the front. Let's see if I could. Hey, where's my? Let's try this. There it is. So it's on the front side, and so it's right here under math of relations. So if you ever just test anxiety or something like that, I totally understand it, but just check that, and it's if you ever forget, all the equations you need are on the equation sheet. Well, asterisks on that one, but we'll get to that one later. If you ever have a question about a equation, just ask. All right, you don't need to memorize equations. So for slope, I'll write it here: y2 minus y, that's supposed to be y1 divided by x2 minus x1. All right, so for letter A, and I'm not going to do all, in fact, I might even not, I'll do this one in letter B. So y2, so x, y, this is x, y, and I highly recommend that you write this out. No, in fact, I strongly recommend that you write all this out, because by writing it out, you slow yourself down. And those are the ones, these are the twos, and you allow your brain to sort of double check itself subconsciously, maybe. It's not scientific, but it's just from experience, from myself and from what I've seen over the many years I've been teaching this. So y2, that would be what, 1. And so the y's have this is often forgot, the y, these have meaning, they have units. And so I'm going to include those units. Y1 is 4 meters divided by x2. So that's 3, and the x's is time. So that's seconds. Minus x1. So that is 0, right? 0? Yeah. 0 seconds, because that's the beginning. So now I'm going to get a negative. I am going to get a negative number. This is negative 3 meters over 3 seconds. That becomes a negative 1 meters per second, and that's okay. It's a negative number because look at, it's a negative slope. It's sloping downward. So that's fine. That's cool. In fact, that's a good thing. You want that, a negative number. It means it's moving in the negative direction, whatever that might mean to, based on the situation. So that's okay. Negative number, negative 1. That's how you do it. All right. If you need more help with slope, we can deal with that tomorrow or in the next couple days. I'm going to just look at B really quick because B is a horizontal line. And if you know anything about horizontal lines, it's got no slope. So like, don't even worry about showing math there because there's nothing to show. I mean, you could do the math and you'll still get a 0. It's okay. But yeah, that's how you do that. So velocity is slope. All right. I will forego the rest because I feel like slope is not something that troubles you. But let's see. Yeah, I get just double checking my answers. All right, we're good. All right, velocity. So number 3, what is the distance traveled during those time intervals? So distance is, you're gonna do that, you're gonna calculate that by summing all the changes in position, ignoring direction. So what I mean by that, from 0 to 4, so from 0 seconds, the distance, the position is 4. And at 4 seconds, this will mess with your brain if you're not careful. You gotta keep things really straight. So in fact, I'm gonna write that down. At 0 seconds, it's 4 meters. And then at 4 seconds, right about there, I don't know if you guys, hopefully you can see the little dot. I could switch, but I think you can see it. It is at 1 meter. So at 4 seconds, it's 1 meter. All right. So to go from 4 to 1, that's 3 meters. So nice and easy. Just find the change in position and you ignore direction. So you might be like, well, it's negative. Yeah, but we're going to ignore that because it doesn't matter if you're walking backwards or forwards or sideways or whatever. You still count that as a distance moved. All right. So how far did you go in that amount of time? So 0 to 7, 0 is 4 meters. At 7 seconds, let's see, we got 7 seconds here, so we're at 4 meters. See, that's going to be a little confusing. So it's like, wait a minute. So this is where you gotta get lost a little bit, and I just illustrated that for you because if you just subtract that, it's 0. It's like, wait a minute, what's going on here? You actually had to sum all the changes. You had to sum all the changes. Okay, don't forget that word sum. So to go from this first line segment is 4 meters. It didn't move at all in this line segment. This one goes from 1 to 4. So that's another, what did I say, 4? This is why you write stuff down, right? It's not 4 meters. It went 3 meters because it went from 4 to 1. Write stuff down. Going from 1 to 4 is another 3 meters. Let's just do all of these, just, because for fun. So going from you're going from 4 meters to negative 2 meters. You gotta be careful here. How far did it actually go? You subtract, and whenever you subtract a negative, you're like adding it. So 4 minus negative 2 is 6 meters. And then, well, it didn't move here because it went from negative 2 meters to negative 2 meters. No change. So what we need to do is say, forget that. We're not doing it that way. We got to find the distances and sum them all. Change in position. So from 0 to 7, that is here. It went 3 plus 0 plus 3. So it went 6 meters. Okay. Distance is honestly the hardest one to calculate. It just takes a little bit of thinking. Well, more than it's like there's no equation to follow here. You just have to add them all up. So from 0 to 12 is the same deal. So 12 is all the way to the end here. So I'm just going to add 3 plus 0 plus 3 plus 6. So what do we got? 12 meters. All right. I'm not seeing any questions on Remind or YouTube just yet. So keep, just, all right. Displacement is the last one. So I need to erase that. Give me a second. So I also want to make sure I hit the right buttons here. It's been, like I said, I'm out of practice. So I'm just going to get rid of all that. Sorry, the answer is no longer there. So displacement, because I want to be clear here. That's the overall change from final to initial position. So what I sort of kind of started doing right here for the third question, that's what displacement is. What is the change from final to initial? The equation that you can maybe use, displacement is x minus x naught. Okay, that didn't come up earlier, and it's not like an official equation that we're going to be testing you on. But if you want to know, this is the equation for it. All right, it's not on the equation sheet, but this is it. So displacement is x minus x naught. In other words, where you are minus where you were. So where you are from 0 to 4 seconds, at 4 seconds, you're at 1 meter. So you're at 1 meter minus, and where you were, where you started, that naught means initial, that means the start. You were at 4 meters. So 4 meters. So the displacement is -3 meters. Okay? And that kind of makes sense if you think about it, because where you were, you started at 4 meters, you went backwards, negative, and you ended up at 1. From 0 to 7, you ended up at 7 seconds. So where's that at? That is at 4 meters. That's where you are. So that's your x, your current position. X means, like x marks the spot, is your position. So 4 meters minus where you were. So once again, 4 meters is where you were. So your displacement from 0 to 7 is 0, because you started out at 4 meters, you walked one way, you walked back, and you're right back where you started from. 0 to 12. So at 12, I ended up at -2 meters minus where I started from, +4 meters. And so my displacement there is -6 meters. Put the little box around it. And that makes sense, hopefully, because you started out in the positive area at 4, you ended up in the negative area at -2. So your displacement is you walked, backwards 6 meters. You walked in the negative direction 6 meters backwards. As you know, is fraught with danger to use that when you're trying to be specific about stuff. But you walked -6 meters. I'll let you digest that a second. Okay, so just remember those things. These are the important things, all right? It's supposed to be an asterisk, but it looks not like an asterisk. I don't know what it looks like. Okay, moving along. So displacement, time graphs. Describe the motion at each letter. So I'm gonna put the answers up. Try to stay ahead of me here, right? Just in your head or something, I guess. I don't know. So letter A, what is it doing? What is the motion like for this position time graphs, this distance and distance time graph? Well, hopefully you know it's not moving. The position, laser pointer, there we go. The position does not change. Yeah, you're just standing somewhere and the position doesn't change. What about letter B? What are you doing? Think about this for a second. There's 2 questions to ask yourself when it comes to motion. And these are the 2 things to keep in mind all the time. What direction are you moving? And in fact, let me just write that down. 2 questions when it comes to motion. Direction and what's going on with speed? Are you speeding up? Are you slowing down? Or are you maintaining a constant speed? So those are the 2 questions to ask yourself. What direction are you moving? And what's going on with your speed? So in this case, because it's a positive slope, it's got a positive velocity. No, I apologize. Well, it does, but it's moving in a positive direction. It is a positive velocity because that's the direction you're moving. And since the slope is not changing, it's a straight line, the whole thing is going to have the same slope. That means that the velocity is going to stay the same because slope is velocity for a position time graph. Okay. Letter C, it's very similar to letter A. You're not going to move. Okay, letter D. It's curvy. All right, get rid of my little pointer there. All right, it's curving upward though. So we got to ask ourselves two questions. What direction is it moving? The direction is positive because it's sloping upward. Okay, it's sloping upward. If you're at the bottom of this hill, if you're here and you're trying to go like to here, you have to walk uphill. It is a sloping upward hill. Therefore, it is moving in the positive direction. But the slope of it starts out shallow and it gets steeper. The slope starts out low and gets high. Let me switch to my pen here. Low, that is a terrible W. Low, no, that's even worse. That's an S, low slope, high slope. What does that tell you? Well, it's moving in the positive direction because it's sloped upward positively, and it's speeding up because it goes from a low slope or low speed to a high speed. At letter D. Letter E. All right, now, first ask yourself two questions. So first ask yourself, because usually this one's the easiest. What's going on with the direction? It's sloping upward. I mean, if you're here and you got to get up here, you're going uphill. It's a different kind of hill, but it is still going upward. Now, you're not going downward. That's the bottom line. So it's still going to have a positive velocity, but it starts out with a high slope, steeper, and it ends up with a low slope. In other words, it starts with a high speed, it ends with a low speed. And so it's got a positive velocity because it's sloping upward. It's slowing down because it starts out with a high slope and ends up with a low slope. All right. Some brave soul say hi on YouTube because I feel like I'm starting to like get that feeling like, is this working even? Well, I guess got some people watching, so I guess it's working. All right, that's okay. You don't have to. Well, you did already. All right. Good. All right, letter F. Okay, it might really. It's not moving. It's a flat. The position is not changing. All right. Good. No questions. By the way, if you ask a question and I've already moved on and you have a question about a previous slide, I will gladly go back to that slide. That is no big deal at all to me. But all I know is this is probably going to take an hour or more and keep moving, right? But if you got a question, please don't hesitate to ask. All right, which graph shows, or graphs, shows the object moving in the negative direction while slowing down? You see how there's two descriptors. There's two descriptors going on here. The direction is negative and it is slowing down. The speed is decreasing. Two things. What direction? What's going on with speed? Negative direction is pretty easy. Look for things that are sloping downward. So letter A, we could just eliminate. These are position time graphs. These are distance time graphs. And so the position is getting, like, it's increasing. It's getting higher up. It's moving in the positive direction. We want negative direction. So letter A is out because it's a positive slope. Letter B has a positive slope. We're going to get rid of that. Letter C, ooh, we got two. So we could eliminate this first part, but maybe it does show it moving in the negative direction. So we're going to put that on the maybe pile because we're going to determine if it's slowing down or not. But let's move on. Okay, letter D, negative slope, it's moving in the negative direction. Good to go. Letter E, it shows a negative direction, a negative slope here. So we'll put that in the maybe pile. Letter F, no, that's moving in the positive direction. Letter G, maybe. Letter H, no. It doesn't matter that it's in the negative quadrant, just so you know. What matters is that it is sloping upward, which means it's moving, it's coming out of the negative quadrant and moving toward the positive quadrant. It's moving forward or positively. It's moving positively. Okay, it's an adverb. It is not the current state of things. It is moving positively. All right, so we took care of the direction. Sloping downward is negative. Slowing down, what that means is it's getting the slope, getting, so let me just squeeze this in here. Slope is, make this grammatically correct. Put a the somewhere in there. Slope is, this is horrible. Getting steeper or shallower. Well, steep slope is a high slope, which means high speed. So if it's slowing down, the slope is getting shallower. All right. So letter C shows it getting steeper. It starts out kind of shallow and it ends up getting pretty steep by the end, the slope. So letter C, it does show negative direction, but it shows it speeding up. It's low slope, high slope at the end. Letter D, well, it's actually, this is a constant slope, which means a constant speed. And so no, it's not slowing down. Letter E, we got the same problem as we had with C, where we got a shallow slope, it's going slow, and then it ends by going fast, a steep slope. So no, hope we have at least one. Letter G, ooh, we got a winner. It's a high slope, ends with a low slope. All right, letter G, and then it actually stops, like this thing stops moving here at the end. There's no change in position. All right, this is one of those things you might need to come back and take a look at and watch again, but that's how it is. Two things, the direction and the speed. Seeing no questions, moving on. Ask questions, and that's no problem. I could go back. All right, which one shows it moving positively at a constant speed? Once again, the two things, we got direction, and we got what's going on with the speed. Positively means what? Positive slope, right? So letter A, all right, yeah, maybe. Letter B, sure. Letter C, all right, the first half, maybe, yeah, positive. Oh, letter G, no, that's a negative slope, so it's not moving positively at all. Same thing with letter E, F is a maybe, G, we already eliminated that. And H is moving positively because it has a positive slope. So this is gonna be just, I can't draw, I can't write. This is supposed to be like writing, all right. Slope, that's an E. All right, cool. Constant speed. Well, oops, that wasn't supposed to go there. Ignore that little line. That just, you know what, I'll get rid of that. All right, constant speed. Also slope, both of these are slope. So direction of slope, positive. We eliminated some. Constant speed means constant slope. You could literally, for a position time graph, for a distance time graph, you can change the word slope with velocity, all right? So if you have a constant slope, you have a constant speed. So letter A, no. Letter B, no. Letter C, nope. Letter E, no. Okay, letter F, nope. Letter G, all right, letter H, yes, it is a constant slope. It is the slope is not changing. So it means it's moving at a constant speed. It's moving positively, all right? All right. Ready? You might have thought I just froze there for a second, but I didn't. I was staring at you. Because you're processing a lot right now. So a couple more like this. All right, which graph? All right. Chat, okay. Yeah, I just got a message. The chat's there, but nobody's chatting yet. That's okay. We're all new to this year, right? So the live chat. You can live chat if you want. So, I mean, you definitely don't have to, but you know, you can if you want to. See, I just chatted with myself because, you know, that's what I do in the back all day. And no, I don't. But all right, so you can. But yes, thank you for. All right, fantastic. See. All right. Okay, here we go. Hey, all right, you guys are awesome. You guys are awesome. All right, positively and slowing down. All right, so hopefully you're getting this, right? Positively slowing down. So two things, right? So always look at slope. It's a distance time graph. You're talking about the velocity, so slope positively. So A, maybe, sure. B, yeah, sure, positive. C, okay, the first half, that's supposed to be an arrow. D, no, that's not positive. E, no, that's not positive. F, sure, maybe. G, no. H, yeah, but maybe. Slowing down means going from high to low, right? High to low. All right, slope, speed, same thing in these graphs, okay? High to low. So does this go from a high slope to a low slope? It does. We've got a winner, but maybe there's more. Let's see. B, no, this goes from low to high. So no. C, high to low slope. I mean, not this part here, but it shows it. On the test, it'll be very clear, just so you know. We probably don't have questions like options like letter C, at least for a question like this, but it does show it. So I just want to be clear. Yes, it does show it at this particular part. It goes from high to low slope, aka speed. So look at this one: high slope, low slope. So F is a choice. H is not a choice because it is a constant slope, which just means a constant speed. All right. I think I got one more because these are the hardest things, most difficult parts. And I got two more at least. All right, but I'm going to move a little bit faster now, right? Because you're getting this. All right, correct. So moving positively. All right, let's just do that. Yes, maybe A, B, sure. Those are check marks, by the way. C, once again, the first half. D, no. E, no. F, I almost checked. Yes, that's a maybe. Not yes, for sure. G, no. H, maybe. Check mark. Okay, speeding up. So speeding up means it's going from low speed to high speed. And if we take speed and just slope, so it goes from low slope to high slope. So this is low. It's the opposite, to high. All right, so remember, these graphs are telling a story. And this is they're written in a language of graph. It's a graph language, and they're trying to tell you a story. And so that's what we're basically doing here. We're just reading the story. So low to high. A, this is not it. It goes from a high slope to a low slope. So no A. B goes from a low slope to a high slope. Oh, yes, this is one. Maybe there's more. Let's see. High to low. All right. And this part doesn't count because it's not moving positively down there. So this one is not it. This does slow down, letter C does, because it goes from low to high slope, but it's moving in the negative direction. So that's why it's disqualified for that half. E, we already discounted. Low to high, so this is going from high speed to low speed slope. So that's nah. G, no, and H is constant, so that's not speeding up at all. It's going the same speed. So letter B is the only one because it goes in the positive direction and the slope is going from low to high slope. All right, next. I got like, how many more of these do I got? Okay, I make this and then I forget how many I make. So, all right, so this is, and then there's one more after this one. Which graph shows the object moving negatively? Holy cow, is that really the question? We probably can do this in our sleep now, I hope, if you've been paying attention. That's it. There's no discussion about speeding up or slowing down or constant speed. So literally, let's just negatively. What does that mean? So don't overthink this. And this is, sometimes you get to a question that's easy and you start to wonder, is it this easy? It can't be this easy. And your brain just won't let you actually have that moment where, no, this is an easy question, because they do exist. So try not to, remember there's two questions that you can ask about the graph. What direction is it moving? And what's going on with its speed? This is only asking one of the questions. What direction is it moving? It's not even asking a question about speed or what's happening with it. So this is an easy one. No. Yes, there, kind of. So not this part. That's X. Negatively, yes, moving negatively. E, yes, moving negatively. F, no, that's a positive slope, so no. G, moving downwards, negative slope, yes. And H, now this is where you might overthink it. You're like, well, it's in the negative quadrant though. Okay, yeah, but the slope is positive. So no, okay? Positive slope doesn't matter to the quadrant. Slope is speed. Speed is slope for a distance time graph. Okay, you only look at slope. If you want to know about the position, yeah, this thing is like way back there or something. It's got a negative position, but it does not have a negative velocity. All right. Next slide. Zero displacement. Ooh, wait, what? Okay. Displacement. If you remember, you don't have to memorize this, but displacement is like how far you are from where you began and in what direction. And if you remember that, you're probably going to be good. But if you want the formula for it, it's that x minus x naught, which is not in the equation sheet. So just remember like where you are, okay, versus where you were, where you started from. That's what that naught means, like the zero, where you were. So anyway, so we got to look for something that has zero displacement, that starts and stops at the same point. This starts here and ends here. Position, I mean, it starts somewhere in the negative something and ends at zero. So no, no, yes. This one starts at zero, it ends at zero. So C shows zero displacement. D, the position starts at zero and it ends up in some negative number. So that's a no. This one starts in some positive area and ends in zero. No, this one starts at zero and ends in some positive number. No, this one starts. Okay, so these do not, and none of these except for C is zero displacement. Okay, that has to do with position. All right, let me just X equals position. Okay, like I said, X marks the spot. Where are you? Okay, are there any questions? And like I said, there's like a 12-second delay, so if you have questions, I could go back, but I'm going to get into velocity time graphs now, and then I'm going to talk about the equations, the kinematic stuff. But when it comes to displacement time graphs or distance time graphs or position time graphs, let me know if you got any. All right, I could go back. This looks similar to what we just did like a half hour ago. Holy cow, it's already 37. See, I told you this was gonna last a while. But now it's a velocity time graph. So this is what I was saying at the beginning. You gotta like ascertain which type of graph is this, position versus time or velocity versus time. And right now I'm telling you it's velocity and it says it, but just make sure you double check velocity versus time. So to find velocity at those spots for velocity time graph, and this is the stuff you write down. I mean, you write down any of this, but in fact, I'm going to put all these on here because I don't want to accidentally overwrite those. So for the first one, question one, velocity, read the graph. Okay, so it is a velocity time graph, which means if it's asking for velocity, you literally just got to find out where is that. Just like with position time graph, if it asks for position, let's literally in the name of the graph. Okay, so velocity time graph, it's graphing velocity versus time. So at 3 seconds, I go over to 3 again, and the position is 1 meter. Ah, see, look at it. I fell back into that. Just, it's not even the case. It's pen. It's, I got to be careful of my units. The units is 1 meter per second. All right. It's going at 1 meter per second. Like it's the same graph as before, and I just switched out velocity. It's okay. It's the units tell the story. Okay, the units tell me what this is going on. So at 4 seconds, it's still 1 meter per second. At 7 seconds, so over here it's 4 seconds, 4 meters per second. Okay, and I'm gonna get to all these things. 9 looks like 9 is at 0. It's not moving at that time. And then at 12 seconds, it's going backwards, apparently, -2 meters per second. You're like, it's the same answers as before, but different units. Yeah, I know. That means it's completely not the same. It's the same numbers, but it's telling a completely different story. So that's why units are important, because that's like what story is it telling? So in this case, it's speed. All right, acceleration, find the slope. I'm not going to do that for you. All right, but because I think you, like I said, you'll know slope. So this is going to be some negative number, meters per second. Acceleration is always going to be the y-axis divided by the x-axis. So you're going to get, in this case, it would be meters per second over seconds. In other words, the velocity is changing some number of meters per second every second. All right. Now, if you do have trouble with slope, let me know in the morning, or let me know, or Mr. Kelly know. All right, it's something we could work on. All right, so displacement. This is something I want to talk about. Area under the line, between the line and the x-axis. And this is important, that especially that last little part, between the line and the x-axis. So since I see I'm going to go all the way up to 12, I'm going to just do all of it. Well, you know what? Let's break it up. 0 to 4. So 4 goes up to here. 7 goes up to here. And then 12 is going to be here. So why did I do that? Because I looked ahead and I saw what I'm going to have to do. Now this is the asterisk from like 40 minutes ago. The equations are not going to be given to you for area of a triangle is 1/2 base times height. All right, the area of a rectangle is base times height, if you will, or you could say length times width. All right, length times width. And so if you forget, let me know, or Mr. Kelly, depending on who's in the room. And that's not a problem. All right. It's been a tumultuous couple of years, and you might not be as familiar with those equations as I am used to. So, you know, like I said, I've been doing this for a while. So that's not a problem if you forgot it. We could absolutely help you. Now, so what I'm going to do is I'm going to start like breaking this up into like different. Whoa, hello. That was weird. Are we on the right one? Yes. I want to change my ink color really quick because I want to basically start breaking this up into. I lost my pen. There it is. Okay. Shapes. So I can't find the shape of the triangle housey looking thing, but I could break this up into a triangle and a rectangle. That's a square. This I'm going to need that, and I'm going to need that. It's going to be separate. This is another one. Let's see, I could break this up into that. And as long as you break it up into rectangles and triangles, you'll be fine with this. All right. I'm going to make this solid line so that I could definitely see. That's going to be my cutoff for question 1. This is going to cut off for question 2, 0 to 7. And this will be the solid line here is my cutoff for question 3. So, okay. So area under the line. Let me just change my color again, and let's just do something fancy here. Highlighter. Oh yes. Okay. You like Mr. Chern. Okay, highlighter might not be the best call here, but whatever. All right, so highlight that, and if I highlight every other one, okay, that's so I could do highlight this. So I'm going to try to find the area of these shapes. You can see where I'm going with this. And I'm highlighting it because I'm really just trying to be clear here. Like you don't have to do all this when you do your own thing. But since I'm like trying to teach you this, highlighter, ink color. Sorry, I really am out of practice here. Let's do this fancy blue. We could do Steelman like knockoff brand blue and gold. Since it is homecoming weekend, I hope you guys, you know, if you did anything for that, I hope you had fun. So let's see. Yes, this is like, you know, and Mom, can I have Steelman colors? Well, we have Steelman colors at home. That's basically what I'm doing with the so-called blue and so-called gold. All right, so pen. Let's not do that color. Let's do, I like this color. Okay, where was I? All right. Oh, my phone went to sleep. You guys are like not talking, so let's put that up back up there. I want to make sure that if a message pops up, I get it. So here we go. Ready? 1/2 base times height. Watch this. This is important. All right. The base is no problem. Going for this yellow triangle here, the base is going to go from 0 to 3, right? So this is going to be, where should I do this? Let's go up here. 3, seconds. Oh, wait, 1/2. 1/2 of 3 times the height. Now here's the important part. You got to watch out for this. You might be like, if you're doing this too quickly, you're gonna be like, well, the height is 4. Well, that's okay. The problem with that is the triangle starts at 1. So what is the height? The height goes from here to here, right? So that's the height. It's 3, and the units for that is 3 meters per second. So what's that going to be? 3 times 3. I can't. 3 times 3 is 9, and half of that is 4.5. So I should probably do this with my calculator. I'm just going to trust myself on that one. I could be making a horrible mistake here. 4.5. And then watch what happens here. This is the kind of the cool part. This is the part that I really like because I'm, physics nerd. The seconds on top here cancels out with the seconds on down there, and you're left with meters. Because what are we trying to find? We're trying to find displacement. Displacement is in meters. Okay, so 1/2. No, now I'm going to do this blue rectangle here. Okay, so the blue rectangle, the base is the length is going to go from 0 to 3. So the length is 3 seconds. The height is 1 meter per second. Okay, so seconds cancels out. 3 times 1, that was easy, is 3 meters. All right, over here, we go from 3 seconds to 4 seconds. So that's 1 second. So let's kind of like do a little arrow. 1 second times the height goes from 0 to 1 meter per second. So it's 1 meter per second. So it cancels out. We're left with 1 meter. Okay, you see where I'm going with this? Will this be on the test? Yes, it will. Yes, it will. But don't forget, I'm taking my time on this to make sure that you get this right. I apparently need a better background. That is not very conducive to text. I'm like, yeah. So yes, this will be on the test. Everything that I've been talking about tonight will be on the test. To some extent or another. All right, this triangle right here. So that's this one right here. This triangle right here. The base goes from 4 to why can't I count? 7. 4, 5, 6, 7. So that's this is a triangle. So 1/2 3 seconds times the height. The height goes from 1 meter per second all the way up to 4 meters per second. So 3 meters per second. It seems very familiar. Seconds are going to cancel out. We'll be left with 4.5 meters. This goes from, I'm going to stop at this point, I think, after I get this part. I'm not. I can't. There's actually something I need to show you to make sure that you get. So the base here goes from, let's see, what is this? 4 over to 7, 4, 5, 6, 7. So again, 3 meters or 3 seconds. The height is 1. Seconds cancels out. 3 meters. Just want to make sure. It does look very similar to the other one. Okay, keeping going. The base here goes from 7 all the way to, why did I do this? Hey, look it. There was no reason to cut that in half. Let's just do this whole triangle. Okay, so that white triangle, I didn't need to break that in half. There was no reason for that. 1/2 the base. So the base goes from 7. In fact, I'm glad I didn't do this because 7 to 9. So that's 2 seconds. This is why we write stuff down, right? Because you might need to change things later on. The height goes from 0 all the way up to 4. So 4 meters per second. Seconds cancels out. 2 times is 8. Half of that is 4 meters. Okay, keep going. Now this is the part I want to make sure you get. If there's a negative number, you have to keep that in mind. All right. So for this particular triangle here, the base is not a problem. The base goes from 9 to 10. So is that 1 second? Now here is the important. It's 1/2 of that because it's a triangle. 1/2 of that. And here's the part that I need you to know. From 0 down to -2. And I just want to make sure you get that. I know most of you did, that you're fine, but that's a -2 meters per second. So we're going to get, I'm not going to squeeze that in there. I could try to. So, it's going to be -1. -1 meters. Okay. Negative. And this one over here goes from, what is it, 10 to 12. So that's 2 seconds. And the depth or the width or the height or whatever the other side is going to be -2 again, -2 meters per second. So we get -4. Seconds cancels out, meters. You're going backwards. That's your displacement. You're going backwards in the negative direction that much. So 0 to 4 seconds. We basically have to add 4.5 plus 3 plus 1. So that's 8.5 meters. 0 to 7 seconds goes up to here. So we take those 8.5. We add 3 more, so 8, 9, 10, 11.5. 4.5 more, so we have 15 and 2 halves, so 16. I'm doing this math in my head, so I apologize if I make a mistake, but you should use your calculator in this case. In fact, for this next one, I'm gonna. So 0 to 12. So literally, I have to. In fact, let me just do a little. Where did it go? Probably not necessary, but you know, there's my calculator. So I'm going to do, of course, now I can't see what I was doing. So 16 is to 7. So 16 plus, and to go from, so we got 4. So 4 plus -1. Wow, I cannot. Okay, -1 plus -4. And incidentally, I noticed, what would I just write? -4. Just to be clear, because some of you guys are making this mistake because we're kind of out of practice with a calculator meter. Maybe this is not a negative number, that's the minus sign. This is your negative. All right, so just FYI. All right, so my answer is 15. You've walked backward a little bit here. We moved backwards. My total displacement is 15. Hang on, let me get rid of that. So and you're like, well, wait a minute, didn't you start, like, you started at 4 and ended at -2? How is your negative? Let me write this down first. Click. 15 meters. How is it 15? Well, okay, that's great observation, but remember, you start at 4 and you end at -2 meters per second. That's your speed. Okay, this is not your position. So like that's the speed. You were going 4 meters per second forward positively for a while. You change your speed a little bit. You blah, 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 you slow down. And so in the end, going these different changing speeds is why you ended up going the, you went forward more than you went backward. All right. All right. Let me digest that a bit. Okay, a couple of these. This was on the review. Which velocity time graph best matches this position time graph? All right, so before you freak out, which is easy to do. Hey, wait, come back. I guess I gotta turn my pen back on. There's only 2 things you need to know. Remember the 2 things? A graph will tell, these motion graphs tells you 2 things that are important that will get you answers to most of the questions that we're asking. Is what's the direction? Okay. And what's going on with speed? Is it speeding up, slowing down, or maintaining a constant speed? So that's what we have to ascertain with this position time graph. It is moving, it has got a negative slope. So that means it's moving, that's supposed to be an N. What is wrong with me? Erase that. It's moving negatively. Is there an E in there? Okay, negatively, there might be an E right there. And it's got a constant slope. The slope is not changing. So constant speed. We're putting forth an answer. I like that. Good. Negatively constant speed. So now we got to look at the velocity time graphs and see what story they're telling. All right. So let's see if you are correct. Letter A, shows a velocity time graph. They're all velocity time graphs, all right? And the velocity is not changing. So we got our constant speed. So check mark 1. However, it is a positive velocity the entire time. So no, that can't be it. Let's just cross that off because it's got positive velocity even though it is constant. Letter B also has positive velocity, but it's increasing speed. It's going from 0 velocity to some positive number. Letter C is the answer because it's got a negative velocity and it's constant. Okay, the velocity is not changing. Letter D has a positive velocity and it's going from some positive number to 0 velocity. It's slowing down. Okay, right? Ask questions, process this, right? There's a couple more. I got a few more of these. So here's another one. They don't call. Do they? All right. I didn't know this. See, I'm learning something now too. I wish I could read this though, Mr. Journal of the Future. Make sure I change the background for the font, the chat. All right. So our two things. What's going on with, what did I say? Direction. No, it started with D, direction. Greatest of all time. All right. All right. Direction, I set to stay focused. Ooh, it might be B. Let's see. And speed. So what's going on with those two things? So direction, it is a positive slope, meaning a positive direction. And it goes from a high slope, aka high speed, to a low slope, low speed. So it is slowing down. All right. Letter A, it's constant. Let's just get rid of these constant ones. This is a constant positive speed. This is a constant negative speed. It doesn't change the entire time. You guys said B, so let's go to letter D and see why it's not. Oh, wait. Okay, let's go to B and C. It is all positive numbers. So you were right on that accord. However, it starts at 0 and ends at some positive number. So it is speeding up. So yeah, good call. You change your answer. Good. And you were going to second guess yourself. That's okay. It's when you start third and fourth and fifth guessing yourself that you run into trouble. So right, this is positive velocity the entire time. It's positive velocity the entire time. Just because it's sloping downward doesn't mean that the velocity is going negative yet. It might, but it hasn't. Okay, it's positive velocity the entire time. And it is going from some positive number down to 0 velocity. So it's slowing down. I'm glad you caught yourself. Next. All right, so this is, I think, the last one like this I'm going to ask you. So just remember what's going on with direction. Holy cow. Direction. That's weird to see. All right, what's going on with direction and what's going on with speed? So you got to ask yourself those two questions every time. So direction, positive. It is sloping upward. Okay, overall. The slope is going upward overall. Speed, it starts out with a high slope, high speed, ends with a low slope, low speed. So it is slowing down. Which means it can't be A and can't be C because those are constant. The speed stays the same. Honestly, if you just look at this one starts high and it ends low. This is slowing down. So once again, yeah. Once again, it's the same exact one. Well, look at what? All right, you're like, but it crossed the line. Okay, I'm switching back and forth really quick between the two. You notice it's the same graph. Okay, all that changed is, are you crossing 0? That's a 0 is a position. Position is irrelevant because we want to know about direction and we want to know about speed. Well, no matter which one, we're heading in the positive direction and we're slowing down. So don't let that fool you. I'm not looking to like try to trick you on the test, but I just want to like make sure that that's all you're looking for is slope. That's it, slope. When you're talking about motion, you're talking about slope. Okay, I switched it up a little bit. These were position time graphs at the top. Now we have a velocity time graph, and these are acceleration time graphs. All right, so I got like 2 of these, I think, maybe 3, 2 or 3 of these. It's been an hour. Nice job sticking with this. Okay, that's how I knew this was going to happen. All right, what's it doing? Okay, once again, direction. As the hour length, I get worse and worse handwriting. Direction, and what's going on with speed? Well, it's always positive. These are all positive numbers, right? So it's going in the positive direction, and it starts at 0 speed and ends at some positive speed. So it's speeding up. So positive is speeding up. Okay. Doesn't matter, however, because, and that's good to know this, but what's going on here? Acceleration Whoa, that was bizarre. Acceleration is accelerate. I'm sorry, I cannot leave that. All right, that was spelled horribly wrong. Acceleration is slope of a velocity time graph. Okay, velocity is slope of a position time graph, but acceleration is slope of a velocity time graph. That was in the very first slide. So all we got to do is look at the slope, and we see it's a positive constant slope. And therefore, the answer is B, because it's a positive constant acceleration. Okay, I'm just, to be clear, I'm going to erase this little line right there. Positive. It honestly, this is one of those ones, as soon as you know it, it is easy. All right. It's it's keeping it all straight too. That's the hard part. So let's take a look at one more. Well, 2 more. I said there was 2 or 3. Okay, so look at this one. All right. Acceleration is the slope of a velocity time graph. What's the slope like going on right here? It's got no slope. And therefore, yep, it's got no acceleration. Last one, like this. It's easy, right? Negative slope, negative acceleration. Hey, I know you're thinking it. All right, negative slope. Here, I know, I'll write this right here. Slope. For a velocity time graph, slope is acceleration. Okay. All right, what is going on here? All right, this is like the quiz question. All right, which velocity time graph shows an object that's moving positively and speeding up the entire time? Moving positively means it's going to have a positive velocity. Okay, so that means it's got to be one of these the entire time. So that means it's going to be either A or B. Because letter D starts, the red one starts out positive, but it goes into negative, so not the entire time. Speeding up means it's getting farther from 0. Okay, this is a velocity time graph. So 0 velocity means it's not moving, and as it gets farther from 0, it's going faster. That means the entire time is A, because it's positive the entire time, and it's getting farther from 0 the entire time. It's getting farther from 0. This will mess with your brain. Which one changes direction? It's not B. It's not B. Like, but it does the thing here. Yeah, well, don't forget, it's positive velocity, and it's still positive velocity here. It's still moving in the positive direction. Yeah, The answer is D. Because for D, it's positive here, even though it's going down, which makes sense because it's changing direction, so it has to slow down. And then it becomes negative. The velocity is positive, and then it's negative. So it's going one direction, and then it's going in the other direction. Letter C is negative the entire time, and letter A and B are positive the entire time, going forward. To be sure, letter B speeds up and slows down, but I might be answering another question. All right, which one shows an object slowing down the entire time? Slowing down, what does that mean for a velocity time graph? It means getting, holy cow, closer to 0. I can write, right? So it's getting closer to 0 the entire time. Letter A is getting faster. We said that. It's good. Okay, letter B, no, it does some weird stuff. The answer is letter C, because it starts out negative and it gets closer to 0. It's slowing down going backwards or negatively the entire time. Stop me if you got questions. What the heck is B doing? Kind of already answered that, so I told you I did. But were you paying attention? What is B doing? Well, remember the 2 questions you got to ask yourself. Whenever you're describing motion, what's going on with direction? And what's going on with speed? First of all, what direction is B going? What happens? Well, the velocity is the positive quadrant. Here's the negative quadrant. B is in the positive quadrant the entire time. So what direction is it going? Positive. What about speed? Well, first it gets farther from 0, and then it gets closer to 0. So it's moving positively the entire time, but first it speeds up, and then it slows down. All right. B is accelerating and then decelerating, and then, yeah. Decelerating is a word you gotta be careful about using, but you basically got the right idea. And the way that we think of accelerating meaning speeding up and decelerating, slowing down, that's fine, that's acceptable. It's close enough, exactly. It's close enough. I was thinking, man, we're gonna go an hour and a half, just like my last year I did this too, an hour and a half, but honestly, this is A, one of the most difficult units, and B, I'm covering everything from August all the way till now in an hour and a half. I feel like it's kind of a good deal for time, and so hopefully you agree with me on that. And honestly, I'm not going to take much longer on this. The kinematics is, well, A, it's the most recent thing we did. B, I was able to help many of you in class. C, well, there's only so much I could say, but I'm going to say it all now, and hopefully the next 15-20 minutes. Let's do this. Ready? All right. You recognize some of these from the review guide too. So here's the thing. You got to get good at this, identifying these things. And the bottom line is time is just a time thing by itself. So like this is time. Seconds is time, right? And I think that's it. On this list. That's time. All right, you know what time is. It's seconds, it's minutes, it's hours. Time. Don't overthink that. Distance. Okay. It's a distance. Meters is a distance. Kilometers is a distance. Millimeters is a distance. Centimeters is a distance. Feet is a distance. Inches is a distance. Miles. Okay, you know what distance is. I don't need to say any of that. And then you're like, all right, what are these? Like this is miles / hours. These are the distance and a time. And that's where we get into these things. All right, speed, velocity. It's a distance over a time. Acceleration is a distance over a time over a time. Okay. And there's a little, like, here, I'll put a little star by this little asterisk because it still remains true, but it doesn't quite necessarily always take that format. That's supposed to be an asterisk. Why can't I draw asterisks? Asterisks. So whenever you see a distance over a time, though, that's going to be a speed or a velocity, but I said speed here, so I'm going to leave it like that. Speed is a distance over a time. Miles per hour, distance over time. Millimeters per year. It sounds weird, but that's still a speed. Kilometers per hour, that's a speed. You can tell you what, let's go back to letter D. This is a distance over a time. Meters per second. That's an acceleration. Meters per second squared. That's our little asterisk I was talking about. I'm going to get that in a minute. I mean, think about like gravity, 9.8, right? Meters per second squared. Kilometers per hour per second. Distance over a time. That's an acceleration. Seconds per hour? That's going to be nothing. That's nonsense. Okay, that's a time over a distance. That's nothing. I just threw that in there for funsies. Distance over time, meters per second. That's a speed or a velocity. Minutes per feet, a time over a distance. Once again, that's nonsense. Centimeters per day, that's a distance over a time. And so we'll call that a speed or a velocity. Honestly, I should just use V for these, but you get the idea. Because when you do the kinematic, when you do the equations, we use V instead of S. It's the same thing. It's, you know. Okay, so not to belabor all this, but what's going on with letter H? Well, if you do meters per second, what does that mean? It means that you're changing a certain amount of meters per second, a certain speed per second. So like if you have like 5 meters per second, that means that your velocity is changing 5 meters per second every second. That's what acceleration is saying right here. But what about these units? What's going on? Why can't we say meters per second squared? Well, if you think about what does a fraction mean, this basically means meters times 1 over second, and then again times 1 over second. And so literally that's why you're able to write meters is on top, and then we got 2 seconds on the bottom multiplied by each other, so that's why it comes out to meters per second squared. It's just a math thing. It's just another thing to memorize, I guess, what it comes down to really. But it's the same idea. Nothing you need to really know. Just be aware that that's meters per that's an acceleration as well. So you need to, like when you see questions like this, you need to be able to pick this out, right? I mean, in fact, I recommend you kind of like do this. Wait, this isn't even an equation though. This is just a question. There's not even a thing to do here. You throw a ball up into the air 12 meters per second. What's the ball's acceleration at the very top? And Mr. Kelly said he mentioned this in class. You might see this again in the very near future. But here's the deal with this. You throw a ball up into the air at the very top while the ball is in the middle of the air. There's only one thing happening to it. That's gravity is pulling on it down. And that gravity, acceleration of gravity, we call that G on the equation sheet. The acceleration is 9.8 meters per second or meters per second. You got it, yes. At all times, it is 9.8. In fact, because it's pulling downward, technically, we're going to want to keep that as a negative. But for now, don't worry about that. But that indicates a direction. But in the future, not now, it doesn't matter. But it's a 9.8 meters per second. That's it. Okay, so if it's in the air and it's asking about acceleration, you just got yourself a free question correct. There's no math to do. Unlike some other questions, this is number 41 on the equation, on the, practice, the review guide. Now here's the thing. I cannot emphasize how important this is to do this, all right? I'm not going to do a whole bunch of these. In fact, I'm barely going to do this one. But you got to do this. Trust me on it. You're just so much more likely to make a mistake if you try to just do this in your head and you throw it in your calculator or whatever. So go through this and do the guess method, the 4 steps, whatever you want to call it. Okay, givens, guess stands for givens, unknown, equation, substitute, and solve. Okay, it comes out to 4 steps. I do the first 2. All right, let me show you rather than just kind of talk. So 8 meters per second, that is a velocity. So do this, like trust me, when you get these questions like this, list out the variables. So velocity, How far did it go? How far did it float? Far, that's a distance. That's your unknown. That's your question mark. 60 seconds is a time. And you might be like, I could just put this in the calculator. I know this. I know. Okay. Some of these, yes, it's going to be very obvious. But do yourself a favor. Take the extra 20 seconds or whatever it takes to write it out. Okay. Especially on a test. And on practice too, so you get used to it. Okay. And then don't skip this part. This part's important because here's the deal. It's like we got all these equations to choose from. How are you supposed to know what equation to use? Well, okay, so we got V, we got D, and we got T, all right? This is the average speed. It's floating away at, okay, right? So you probably know where I'm going with this, but it's okay. So we gotta look at our equation sheet and look at the very top. Okay, let me just kind of ambiguize this a little bit and then smallerize this a little. Okay, we got all these equations to choose from. How the heck are you supposed to know which one to use? Well, like I said, we have average velocity for our orange. I don't know. This is the stupid stuff I used to do as a kid. They turn into physics problems now, throwing crud into, anyway. And we've got distance and time. So we're gonna literally use this equation right here. All right, that's how we know. That's how we identify which equation to use. So I'm gonna write that down, just empty with just the letters in it. V, average, I guess, is equal to distance or displacement over time. All right, now, we want to know how far did it float? That's letter D. There's one of two ways you can do this. You do whatever is comfortable, okay? I'm gonna do both really quick. I'm gonna set it up. I'm not gonna actually solve it. You can. This is the way I like to do it personally. I want to solve for distance. So I'm going to erase this little line first. And then I'm going to change colors so that, because I'm the teacher right now and I want to make sure I'm clear what I'm doing. Let's change it to red. I'm going to try to get time out of there. Okay, I want distance by itself. So time on top, time on bottom cancels out. Whatever I do to one side, I got to do to the other. So I end up with time times average velocity is equal to distance. Boom, done. So now I can just plug that number in. And so I get distance is equal to the average, and I like parentheses. I use parentheses for everything, especially because we got these units in there now. Mr. Jern and Mr. Kelly were like, units, you know, make sure you include those, times the time, 60 seconds. It's like, boom, I know the seconds are gonna cancel out. My final step is gonna be whatever that is. 60 times 0.8. I'm gonna skip that part. But whatever it is, you know what? I'm not gonna skip it. 60 times 0.8, 48. So I know that the answer is 48 meters. I put a little box around it and I'm done. That's one way to do it, okay? And I personally like to do that. That's how I was taught. But you know, you might have been taught this alternate way. So the alternate way, you probably know what it is. You start with the same average distance over time, and then you just plug in the numbers as is. So 0.8 meters per second is equal to, it's the same thing, it's just, you know, slightly different step. Distance divided by 60 seconds. And then you go from there. Now you solve it, all right? Either way is fine. I don't care. As long as you write down and then you get like distance. I mean, you got to do all the math, of course. You got to do all the algebra. But either way you do it is fine by me. But do show all your work here. And I just want to be clear that this part is the physics part. And if you could get this far, you're good. This last part is algebra. If you could do this, you need to learn to do this, but it's a separate skill. So if you have trouble with this part, that's a separate part than actually trying to compute the answer. So just keep that in mind, okay? All right. Okay. One or two more, literally this is it. I want to show you this and then I'll be pretty much almost done. This is number 47, driver. And you're like, wait a minute, I got questions. I know. Don't worry, I'm gonna address those as well. But I want to talk about acceleration. A driver of a car going blah, 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 slams on his brakes. So, and avoid hitting a pumpkin that mysteriously fell out of the sky in front of him. It takes the car 1.3 seconds to stop. What was his acceleration? All right, you know what? Let's get the easy thing out of the way. What I think is easy. The question mark. What is his acceleration? All right, done. We don't know what that is, but we know that's what we're asking for. The driver is going 32 kilometers per hour. That's his initial velocity. He slams on the brakes. It takes him blah, blah, blah to stop. That's going to be your V final. You got to look for these little word clues. So VI is 32 kilometers per hour. Write these down. Not this, whatever. When you do these, write these down. Once you write it down, you don't have to think about it anymore. You have to like keep this stuff in your head straight. And if you're spending effort trying to keep this in your head and keep it, it's all swirling around in there, you're just so much more likely to mess it up. So by writing it down, it's there. Now you don't have to think about it anymore. And in fact, your brain may be like, wait a minute, I just made a mistake. And you're less likely to mess up. So now what else? Oh, the time. It says 1.3 seconds. Seconds to stop. Okay. So once again, and then, I'm not going to do the math on this one. It's like, all right, we've got, hello, there we go. Let's make sure. Yes. All right, good. A, VI, VF, and T. Definitely not the first one anymore. We don't have distance, so it's not gonna be this one. It's not gonna be that one. We don't know distance. Once again, distance. I skipped one on purpose because I wanted to show you why it wasn't gonna be the other ones. But we got VF, we got A, we got T, and we got VI. All right, we are good. You're like, okay, well, we're still gonna have to solve for A, but that's okay. It's okay. So I'm gonna write that equation down, and then you would go from there. Well, I'm going to try to write it down. Oh, I always mess it up. Is it? I'm pretty sure it's VF, but because I'm not 100% sure and it's getting late and I don't, yeah, VF. Okay, like you're a physics teacher, you should know this. I know, but I still check myself every now and then because I make mistakes. VF equals VI. All right, good news is you probably get what I'm saying here. AT plus VI. All right, I was going to write it backwards. That's okay. Let's write it forward though. A times T plus VI. And then that's the physics of it. Now you take it from there and you do the algebra of it. Okay, you solve for A. Either rearrange the equation ahead of time or plug in the numbers and then solve then. All right, I believe Mr. Kelly wrote this on the board. It's not on the equation sheet, but acceleration is VF minus VI divided by time, and that's a pretty standard equation. That ends up being the slope of a velocity time graph, in case you're wondering, because if you think about it, the top of it is the y, the change in y, the bottom of it is the change in time, but it's all related. You got it. All right, I just saw you saw the answer or put the answer down, so thank you for yes. Okay. By the way, if you want me to finish these answers, I'm not going to do it on the live stream, but I could show it to you in class tomorrow or whatever. And hopefully, I think the key is online. If it's not on the OneNote, then we will make sure it's there. If not tonight, then tomorrow. All right, so the key will be the written out answer key. If it's not there, I think it's already there, but if it's not, we'll make sure it's there later. Or in the next next 12 hours. Well, let's say the next 15 hours. I don't know, sometime tomorrow. We'll make sure it's on the OneNote. All right, blah, 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 going down the street with an accelerated. Oh, hey, wait, I blah, blah, blah through this. Don't blah, blah, blah through stuff. Make sure you read it carefully. Look for these clues. It started at rest. What does that tell you? VI is 0. I usually do that little slashy thing. You don't have to. I just do that to make it clear. An acceleration of, I'm not going to do much more of this, but I just want to make sure we write this down. Meters per second squared. It's how fast is the tire rolling after? Oh, that screams VF. How fast is it going after a certain amount of time? And it says 20 meters. So what is that? That's a distance. Whoop. All right. It looks like I'm going to, oh, no, it's going to be, we got D this time. So I can't use the same equation as last time, right? We got VI, A, F, VI, A, VF, and D. So let's take a look. What do we got there? All right, we got D. That's good. Wait, are we seeing this? There we are. We got D. I got two screens, so I forget which one you're actually seeing, which we're not. We got D. Perfect. Half. Okay, it's just a number. A. Yes. Time. Oh, no. What? Oh, no. I just changed the official equation sheet. Let's not do that. We don't have time. Okay, so this equation is not going to work. Let's go down to this one. Once again, there's time. Okay, we can't use that one. Right? Yeah, there's no time. This first one doesn't have D, so we can't use that. Okay. VF, yes, good. VI, we got that kind of. I mean, we're trying to, it's 0, but that's fine. It's 0 squared. 2, okay, that's a number, fine. A, all right, we got that. And D, we got 20. All right, here's our winner. We're going to use this equation right here, VF. All right, you know what? Rather than try to memorize this, I'm going to put this on my other screen. Oh, hello. Just did something funny. That's not good. All right, let's not do funny things here at the end of this. End of all things. Let's write this out. So, and then I'm like I said, I'm not going to continue this. So I'm going to use this equation: VF squared equals VI squared plus 2AD. And the reason I'm able to do that is because, like I said, I've got these variables. It shows me that that's got to be the equation I'm going to use. So once again, that's the physics of it. You do the math from there. If that's the trouble, I can help you out tomorrow. Mr. Kelly can help you out tomorrow. Okay. You're like, I'm missing one very important type of question. I know. These ones, right? Okay. I'm going to start by saying a couple things. One, there is one whole question, I believe one question on the test like this. Okay. So please do not spend an inordinate amount of time on this. 2, I put a link to a video that I made like 8 years ago in the chat or in the description. I describe how to do a question like this. All right, so I'm not going to spend the time right now because we're at an hour and a half and I want to be done. And there's only one question like this on the whole test. And that leaves me with one last thing to say. Well, first of all, I guess, are there any questions for Unit 1? While I'm waiting for the delay and for you to think of it, when you're studying for this stuff, do not forget about the easy stuff. All right, go through the review guide. Notice that most of it is not those hard questions. Well, I mean, that's all relative, right? But spend the time you need to on the easy and the medium hard stuff, and use a strategy, right? Circle the questions that you have no idea how to do. Circle the questions that you don't know how to do. Circle the questions that are the hard ones. Come back to them. All right. If you find yourself spending a huge amount of time on it on the practice, on the review guide, take that as a hint that maybe you should move on. All right. You're only going to get an hour for this test, not even an hour, 50 minutes. You got to learn to pace yourself. All right. So questions like this, yeah, it'll be on the test, but it's one question. Okay. So take that for what it's worth. All right. All right. I think that's about it. The test is on Tuesday. So you've got time to ask me questions. You got time to ask Mr. Kelly questions. The good news is sometimes there's student teachers that come in that don't know what they're doing. They don't know the content very well. Mr. Kelly knows the content very well. He does. So you could ask him, and he is going to explain it differently than I do, and I'm going to explain it differently than he does. I mean, and that's a good thing. But ask both of us. Ask one of us questions. All right, we're both there to help you. That's why we do this job. So you are not bothering us if you use Remind. I hold up my phone, but you're not bothering us if you use Remind to ask us questions. We might not be able to answer you right away. Like, 10 o'clock tomorrow night, probably not going to get to your answer to answer your question. But please ask us questions. All right. All right. Well, you all have a wonderful evening. Thanks for joining this. Hopefully this was helpful to you. Nice thing about it being on YouTube is you just rewind it, watch the parts you need to again. All right, so have a good evening, and I'll see you tomorrow. Bye.